So moving forward, we're using, or we're going to isolate the top rail and the bottom rail so that we can modify the bottom rail, right? In order to do that, we will be using, as Dee just pointed out to us, the list item node. And the list item node is going to allow us to tap into the list of lists here. So each of the panels came out, each of these panels that we generated, right, all these horizontal louvers that are right now very flat and aligned, they're all groups, right? So every single one of these darkened tabs is a group of lines. When we use list item, it's going to grab that index item from every single one of the groups. Does that make sense? You don't seem convinced. But anyway, so under set and list, list item right here, it's going to ask for the list of items and then the index that it's going to take. So the list of items obviously would be the edges. And since it's a dotted dashed line like this, it comes out as a group of 4 edges. So because there are 4 edges in every panel, we make a slider from 0 to 3. Whoops. And when I plug that in, and if I select item, what you'll see is that the item component is highlighting at index item 0. Index item 0 in every single one of those lists is the bottom curve on every surface. So that's good. We need to keep this. So I'll grab this and move it down. And then I'll copy and paste and I'll move one above. And this one I'm going to label as bottom edge. And this one up here, I need to find which index item is going to be my top edge. So I'll move to 1, and 1 isn't it, and 2 happens to be the top. So that's good. I'll group this as top edge. So at this stage, we can move forward to start modifying the geometry itself. And now is really where we have to start thinking about strategy. So what did I mention our strategy was? What was our major action feature? When I talked about it's almost exactly like as if you're doing it in real life, right? You have a flat horizontal louver that you're grabbing at the center and you're peeling it up. Rotate, yes. So we're going to rotate. In order to rotate, we need a couple of things. What are some of the things that you need in order to do a rotation?
Set the point where
Yes. You need to set a point where you're going to start your rotation.
Yeah.
And then for us, the key is we're actually rotating something. So what is that thing?
Surface.
Close. I mean, so think about it, right? You establish a series of points along the top rail,
Range.
right? Huh?
Range.
I don't know what you mean by that. But anyway, so if you think about it, right, we establish a set of points along the top rail because we're rotating around that top rail. As we peel it up, we're rotating around the top rail. But in order to do that and to create a smooth curve, we need to do what to the bottom rail? We need to also create the same number of points on the bottom rail because the points are going to be what we rotate around the points that we put on the top rail. Can you envision that in your heads? Well, let's build it and then you'll see. Anyway, so really the way that I'm going to be doing this is I'm going to create what's called perpendicular frames. Okay, so this is something that's now new. It's not something you've seen before. Perpendicular frames along the top rail. Because when I rotate it, I'm going to rotate via an axis and a base point. So perpendicular frames will give me both of those in one node. The bottom rail I'm going to divide. And so under the top one, I can grab perpendicular frames from curve and division, and it's this one right here called perp frames. It's going to ask for the curve to divide. It's going to ask for the number of perpendicular frames. And then A is, I don't know exactly how A functions. There are a few of those I don't really use that often. So anyway, the line can actually be a list of lines, which would be all of the top rails. So we'll plug that in here, and you see it gets really, really crazy. So those are going to be our rotators. We need to define the number of rotators we're going to use on each rail. And I mentioned before that I used 5. So you could use a static number or you could use a slider. In this case, I'm going to use a slider, and I'm just going to start with 5. And I'll plug that in to perp frames there. Actually, I lied. I'm not going to use 5 subdivisions because that's the number of subdivisions, segments. I want 5 frames, which means I only have 4 segments. Like that. And then the other one is to divide the bottom curve. So by dividing the bottom curve, I go to division again, and I do a divide curve. So those two are under curve and division. And the bottom curves then get plugged into the C for divide, and you see that it starts populating those lines with points. And when I plug the count in, then you'll see that those points are aligned with the perpendicular frames. It's all coming together, right? So that was a little bit of a long-winded explanation for all those things, but I think it was good to think through it. So I'm going to stop this particular video segment here, and then we're going to move on to generating the actual rotator, which will include the curve on the side. Oh, this is a new file. So we're actually going to create a curve on the side that we're going to use as a basis point that's going to automatically update the lip of the curve and how much we're pulling it. Any questions?